So, for those of you who have not met before, my name's Ryan. I have been in industry for 30 years, and most of my time has been in this surrounding space. I'm probably most known for my work related to certificate stuff. I used to be an advisor to Let's Encrypt. I used to be CTO of GMF Global Sign. I participated in the ITF on numerous certificate-related standards, author of TLS. I figure there's a lot more knowledgeable people about the current state of SPIFFE and SPIRE than myself today, but I do have a lot of knowledge about the history that kind of got us here. And I'll tell you a little bit about what sort of the journey that we're on and my take on it. My most relevant to our conversations today is I used to be head of production, head of product for the production identity infrastructure at Google. I was responsible for all of the certificate-related products in Google Cloud. That included Anthos Service Mesh and other things. So I much love what you all are doing, and I'll tell you my version of the history that got us here today. So,
Ryan, you might have to.
A little bit louder, okay. I sit around and I think about sort of what got us here a lot, not just for today's talk, just overall. And so for me, it starts in the 80s. And in the 80s, all of our systems, in fact, we were just having a conversation about automotive systems and sort of how everything trusts everything. And that was the 80s. We didn't build security into anything. We just assumed that our networks were secure. I know this is not new, but it's useful context. In the 90s, we started to try to put firewalls around things, antivirus around things. We're going to take this insecure design and try to board it up. And as we got into the 2000s, we decided maybe we should pay down our tech debt and try to address some of these things more inherently. As we progress through the 2000s, we started to ask the questions: how do we build things so they're actually secure? And then today, we're sort of figuring out how to do this at scale. And so that's my high-level view of kind of how we got here. But on a more concrete level, why is it that we're doing machine and workload identity today? I actually think you can draw a story arc around history and standards a number of different ways, but for me, I think the consumerization of security really started with the iPhone, because the iPhone took away a whole collection of problems that people had to worry about when using their phone. Simple things like unlocking my phone. Something I have stories I could share about the challenges of getting supported in Windows, and how nobody wanted a fingerprint sensor on their phone, Ryan. So I think the consumerization of security technologies inside of these devices that we now all carry in our pockets sort of gave a legitimacy to the noise that security professionals were making about we need to do this right. And so as we go down this journey, actually I'll need my glasses because I won't remember everything. I think that after that, we started to see people shift away from cloud, which created this opportunity from on-premise to cloud, which created this opportunity to rethink the way we were building things. Because at the time, we were thinking about software as a sunk cost that we would pay once, and then we'd run our business on it forever. Sort of the antithesis of the way that we run security systems today, right? Where we're continuously investing and updating and improvements to the systems that we have to avoid bit rot if for no other reason. That same transition started to happen to all of the software that we use, from word processing, spreadsheets, and email and everything. And this created this problem of how do we deal with authentication for users in a disconnected world where we don't have the same assumptions of a network protecting us. And we came up with a lot of super secure and not usable, and horribly secure but very convenient ways to be able to solve that problem. And jumping a little bit ahead, I think right now what's happening with FIDO and passkeys, I think is a fantastic sort of response to that, where again, kind of the same sort of techniques that are happening blindly for us inside of our devices are now being for talking to their head ends, is finding its way into the web applications that we use. And I think this is all relevant to what we're doing with workload and machine authentication. We're sort of re-envisioning the fabric in which our applications run on. And this, this journey is, in my mind, I think part of an identity revolution, but I don't think it actually started there. I actually believe it began with the web. All people come with bias. I spent a lot of my career on the web and web PKI, so I see everything a little bit through that light. But you know, we went from, in 1995 to 2019, 0% TLS adoption to roughly 98% TLS adoption on the web. And along the way, we learned a lot of lessons about how to manage certificates. At least that's the way we used to think about it, is managing certificates. I have a slightly different view on what we're actually doing. But most of that growth happened in the last 10 years, and we'd all would say, let's encrypt. And so to my let's encrypt brethren, you know, congratulations, keep it up. But I actually think it's mostly Acme and automation. So when I look at SPIFFE and SPIRE, I think one of the important things is that it's embraced, you know, automating not just the life cycle of the credential, but the life cycle of the entire problem set. And this is actually, it's not like Acme was the very first certificate enrollment protocol. It's far from it. There was more certificate enrollment protocols that you could shake a stick at. It's the first one that actually looked at from the very beginning of the identification of a device to the issuance of the certificate, instead of presuming that was taken care of by somebody else. And that is what opened up the rapid adoption of TLS in my mind. Again, free and competent certificate authority, you know, big contributor, but the major impact on a long-term basis, I suspect, is actually going to be seen as Acme. So, but what about hardware? Early in my career, I was at Microsoft. I spent 15 years there. I spent 15 years at Microsoft, 2 stays, and when one of those stays, I worked on things like trusted computing, including the TPM. And when we were doing the trusted computing work, you know, one of the things that we were always talking about was how this was going to be the foundation of network communications, workload, and machine identity in deployments, and you know, how hard it was going to be able to protect keys, and how this was going to be the foundation of how we, you know, solve the, you know, at the time we didn't call it ring -1, 2, and 3, but you know, these early hardware you know, level attacks that we knew were going to happen. And so what I think is, I'll say, beautiful about SPIFFE and SPIRE is that it's taken all of the last 25 years of work in this area and kind of bundled it together into a comprehensive solution. And not only a comprehensive solution, it's sort of, to a degree, and I know it's not strictly easy, but it's consumerized it in many respects. It's for lack of a better term, weaponized, applying the techniques that big companies like Uber, who's gracious enough to host us here today, to make it so even smaller organizations or even large organizations without the same technical resources can get the benefit of that 25 years of investment without having to be a rocket scientist and reinvent the wheel every single time. So what are the key takeaways for me of that last 25 years? I think the first one is identity management is key management. So in that regard, I'm no fan of bearer tokens and moving everything to well-managed asymmetric keys. And you know, you get down to frequently negotiated symmetric keys. This is the way we want to live. This is a good life. We also have learned that without planning, key management fails. Every time somebody tries to roll a root certificate, every time somebody tries to roll a key when they have never planned to roll a root certificate or roll a key, problems occur. You know, in the most simple cases, you could think of pinning. On the surface, it sounds really simple, really beautiful. You're like, I am going to pin to my key, and then your site goes down because you didn't consider management of that key. You didn't consider all of the things that are necessary to be able to do so reliably and competently. So again, key management fails when we do not plan. And I think coming back to that iPhone element, usable technology is used technology. I think that I've done work on high performance computing, Kerberos, and lots of very complicated systems over the years, and some awesome security technologies that I've worked on basically died, not because they were not good, but because they were not deployable, because they were not easy to use, because they were not easy to manage. And so I think usable technology is use technology. And oftentimes this one is a little contentious, but one key lesson that I personally have taken away is key rotation often negates the need for revocation. And a system that we deployed at Microsoft in 2007, we were reissuing certificates for every desktop in the Microsoft enterprise every day. I think it was around every 10 hours. And we were able to do that back then because we had synchronized clocks, we had a well-managed infrastructure where we were able to do that. And on a practical basis, you can't roll out revocation across a fleet like that in a period shorter than that. Not everybody can roll out 10-hour certificates, but it's a lot more practical of a problem. And you could see even manifestations of that in the way we did production identity at Google, in the context of let's be honest with ourselves on what we can actually accomplish in the context of this very hard problem of revocation. So my crude reductionism there is key rotation often negates the need for revocation. So what does this look like as we start to take this journey from all of this big pile of technology to how we do workload authentication? I know all of you understand SPIFFE and SPIRE intimately, so I don't try to go into this very much, but as Evan said earlier, everybody is jumping on the SPIFFE bandwagon. I think this is fantastic. Some of the things that Google is doing, we were working on for a long time while I was there, to be able to get the front end to do mutual TLS, to be able to rely on SPIFFE credentials for API credentials, these sorts of things. They are quite hard to do at a very large scale, given the way some of these technologies work. And it's really exciting to see Google being able to come forward and talk about what they've been doing in this space, as well as talk about seeing Microsoft do similar things. This broad adoption, I think, opens up a number of opportunities. But again, I think it comes back to usable technology is use technology. It's increasingly common for people to be running cross-cloud, whether just for some machine learning workload that I want to be able to run in AWS because AWS has something better than what is in Azure, that is better than what is in GCP, and being able to have a common identity substrate actually does begin to deliver on this value proposition that cloud is cheaper, more flexible, and migratable. And I think that we still have a long way to go to get to that the holy ground, but I do think it's a really important step in that direction. The other thing that I think maybe I'm even more excited about is finally seeing device attestation become a thing at scale. I mean, this is a technology that we were working on in Palladium in 99, 2000-ish at Microsoft, and it wasn't to be able to take your computers away from you. It was to be able to do what we're trying to do now, which is tie hardware and keys or software to hardware and keys to hardware, so that we could make reason about the way that computers actually work. And it's crazy that this whole journey has taken as long as it has, but it's neat to see it all come together. So why do we care about machine and workload identity? I think is a good question. Sometimes I'll talk about what does a good security program look like, and the overview of that talk basically is it's not that you don't get hacked, because everybody will get hacked. It's not that you have the most shiny audit program. It's literally that you can tell when you've been hacked and you can respond competently. And responding competently is principally about reducing blast radius. That can sometimes be about how quickly you can respond. It could be about reducing lateral movement inside of the network. It can be about being able to reason about something that has happened elsewhere in your network and whether or not it could have impacted this network. And a lot of that's about being thoughtful in the way that you design your systems so that they understand how they communicate with each other. And SPIFFE and SPIRE is clearly something that's super important to that problem. So when I think all of this production workload stuff, I think the biggest theme for me is probably reducing blast radius. So when you ask yourself, 25 years, why did it take that long? That's at least one career. or approaching one career. And I think the common theme as I look back is anxiety for change. An interesting example is at Google. I was at Google for 8 years this last time. And in that 8 years, we had to do a number of route transitions. So where we would get a cross sign from, so we wouldn't break Android One devices, for example. Something that a lot of people don't realize is that change can take 2 years. So if you think about like making a production change inside of a SPIFFE Spire deployment, we would basically doing the same thing for Google.com would require us to roll out a change, wait 3 weeks for people to complain about some esoteric device broken in some weird corner of the world, and then we would roll the change back, and then we would do the same thing again after we gave them some time to remediate, and then we'd do the same thing again and again and again until we get to the point where we've given you 2 years. That's all we're going to give you. If you haven't figured out how to fix it by now, that's on you. And so that breaking of things comes with anxiety. And so how do you manage that anxiety? And I think a couple things is removing human interaction in systems. So for route management, which I know is a component of what we are talking about in this community, removing manual actions about rolling out certificates and keys. Like, why should anybody ever have to touch a certificate and a key? There's no reason that should happen. It's sheer lunacy as far as I'm concerned. And so solutions like SPIFFE and Spire are solving that problem for people in a way that at some point our children will never have to worry about what a certificate and key is, but they'll probably be using them. And so understanding the way that your systems talk together help us understand what our exposure is through this sort of implicit visibility that we get. So when every Tuesday comes, or first Tuesday, whatever the patch Tuesday happens to be, we can actually say, is this relevant to us? And we can say, yes, it is, but our exposure is limited to our production workloads right now. And what a powerful tool to be able to say, you can have your weekend, we'll fix it on Monday. And so I think a big piece of what SPIFFE and Spire deliver is anxiety reduction. So if we can make things easy, we can also have peace. And so a big part of that is enabling people to be more productive. So fundamentally, as a manager of teams, the thing that I want is my teams to not focus on the mundane and esoteric. I want them to produce business logic that produces revenue. And that's not to say what we do as platform engineers, and I still like to see myself as a recovering engineer, is not business value, but what we're doing is we're unlocking the productivity for everybody else so that they can actually pay our salaries. And so I actually view SPIFFE and Spire as a productivity technology. And I think by eliminating, there's two ways to eliminate the problems that we work on. One is to ignore them, which basically would be the 80s through the 2000s. And then the other is to do something about it, which would be the 2000s through the 2023s. And I think we're getting to the point where, with SPIFFE and Spire, at least for production, workload, and machine identity, we have a credible story. So the thing that I think is most interesting maybe is that this is all happening for this shift from bearer tokens or no tokens to sort of happening at the same time from passwords to, we'll say, passkeys. Not that passkeys are the first cryptographic identity for users, but they're probably the first that's going to get adopted in mass scale. And so as a business leader, what I want to be able to say is that I have one story and it's mostly true. All I hope for is mostly true. And if I say we are using cryptographic-based identity to authenticate all users and devices, I can have faith that I get most of those properties. And I think that what SPIFFE and Spire is doing is sort of, the sister effort, as far as I'm concerned, is this broad adoption of passkeys and other similar technologies, because this will allow us to have a much simpler story as we look at the larger enterprise. And so I view a component of this as, this was supposed to be, by the way, skipping, according to Midjourney. I think the prompt was 2 IT professionals skipping and happy. There is no skipping in this picture, but so the journey from here to there. So I get the feeling from the talks today that everybody, at least in this room, I'm not sure about online, is either actively participating or knee-deep in becoming an active participant. So some of this is probably motherhood and apple pie. But you always need to have a plan. And the migration from existing workloads to this, they can take time. And it's probably not so much the SPIFFE and SPIRE component as much as it is the refactoring of our components to actually be able to work as a cloud-first technology that eats the majority of the things. So reasonable planning for how we're going to get there and spending the energy up front on the plumbing that will enable those workloads to transition seamlessly, which that plumbing does certainly include SPIFFE and SPIRE. I think something that people often forget about is the ongoing obligation that comes along with managing certificates. It's like, okay, I've got a CA, I'm gone. The reality is that everybody I know over the last 30 years who said, okay, we're good, and then all of the talent has walked away, has come around and said, uh-oh, there's this box in the corner, we don't know what it does, I don't know how to manage it. And so having like long-term plans about how I'm going to deal with certificate authorities and keys and things like that, I think an organization needs to pay a lot of attention to, and not just treat it as another workload, because it ends up being the substrate for all of the other infrastructure. And that's probably that. So I grew up in the 80s, so I got a little bit of A-team in me, but I do love it when a plan comes together. I do think SPIFFE and SPIRE is bringing the interoperability that is necessary to enable these cross-cloud workloads. I think that in the end, this is a very tractable problem, and I'm excited to see that today's event we have so many people participating, and it looks like the future is bright for SPIFFE and SPIRE, so I think you guys got this. When I think about what's next, though, the one thing I'll leave for you to think about is, cryptography is always about probabilities, and the algorithms that we have today are probabilistically secure today, but they won't be probabilistically secure tomorrow. For some value of tomorrow, I think the next question is whether it's PQC, which I'm sort of focusing on in this slide, or some future algorithm that needs to change. I think it's important to understand that another trend that has taken place is every time we change algorithms, it takes 25 years. So if you look at the history to go from 0 to 100% adoption, it's something in the order of 15 to 25 years. That's cryptographic libraries, that's standardization of the algorithm, standardization of the protocols, shipping the new libraries, doing all of these things. And so one thing to keep in mind as you continue this journey of evolving SPIFFE and SPIRE is how does PQC factor into your story? How do you, because you're in a kind of a DevOpsy environment, I think the library problems are less of a challenge for you, but are you making assumptions in the way that the system works about what cryptographic algorithms are in use? Something to keep in mind as you do this, continue down this journey. So that's my talk. Any questions? Okay, well, thank you.
I have a question.
Sure.
I'm curious to hear your thoughts on how you might compare and contrast some of the lifecycle automation stuff for the open web like Acme to, something like SPIFFE, which is built more for production identity, internal systems, things like that. Because, there are a lot of similarities. It also feels like there are some pretty big differences. And I think they're also complementary. And so I'm curious to hear how you see those things kind of fitting together or not fitting together.
I'm kind of a broken record when it comes to Acme because my position is almost Acme for all the things. But the difference I think that exists in this ecosystem is that there's a whole lot of different moving parts in the control plane here that make it very sort of specific. Today, I think you could have actually delivered the functionality that we have in SPIFFE around Acme. Does it make sense, given where you are, to retool to do it? Would it have made sense if you started today? Maybe. But I do think that for organizations, a common thing when I talk to big and small organizations is that they hate that this platform does it this way, that platform does it that way, that platform does it that way, and they want to be able to reason about their enterprise as one sort of simple, flat thing. I think in your case, as you look at your direct customer, like the people who are operating infrastructures and building infrastructure, they actually, I don't think that is as large of a problem because you are solving that problem for them within their domain space. So I don't think it's as big of an issue. But as SPIFFE bleeds into IT, the side of the house, I'm like, well, is that the right thing? Or is there a journey like that's happening with OITC right now and SPIFFE where there's some convergence to keep it aligned? But I think they want, Adam Langley says, have one joint and have it well oiled. And so my attitude towards Acme is let's just have that be our joint unless it doesn't make sense. I think in this case, it probably doesn't make sense, but it depends on where the ecosystem goes.
Mm-hmm. Awesome, thank you.
A clarification question, if I may. You talked about bearer tokens and you don't like them and you like identity documents more. And I was wondering if that was really, like, what does a bearer token mean? And the context of that is that SPIFFE supports both, right? You can use a JWT and send it as a bearer token. You can use X49, send it over TLS, whatever. So are you really comparing things like random strings with no structure and you call that a bearer token?
Anything that I can steal, so every time I share a secret, it's not a secret anymore. And so when I say bearer tokens, I'm really talking about, I would rather prove that that I am something and then you decide, than I would here is this shared secret. So it's really more shared secrets when I'm talking to that. Structure, I don't really care. I want to be able to prove who I am and then you decide what rights I have versus take my secret and steal it. Because there's buffer overflow on a front end system. That you cause a crash dump. And now that secret is in a core dump file sitting on the disk, and somebody walks off with a key. You might think of a recent event where that might have happened. And so I would much rather you have that core dump contain a signature rather than a key that was shared with it, and that's not specifically that scenario, obviously, because it was a signing key. But so basically, I'd like to prove things that I am somebody versus give you enough to prove that you are me. I don't know if that makes sense.
Would the primary difference be the lifetime of that proof? So like a shared secret would be long-lived and that's why it's dangerous versus a proof can be refreshed every few minutes. And so even if you steal that proof or if you steal an X49 certificate.
It is a mitigator to like short-lived secrets, even when you're talking about an asymmetric key. I think shorter is better as a general rule. There's like a threshold for like how short can you get and still have somebody not get a phone call, right? And so the problem with, once you get super short, you're back to Kerberos. Now, my first security job was at a company called CyberSafe, and we did Kerberos, a bunch of Kerberos standardization. So once you get down to the point where you're changing your tickets every single day, symmetric key is fine as long as you have a framework around it that gives you similar properties that you're getting in Kerberos. That being said, even Kerberos doesn't run on the internet for good reasons. And so my reductionism is public keys for all the things, negotiate session keys for everything else. So, but again, there's different solutions for different problems.
Quick question, could you elaborate a little bit more about how to fight fear of changes? Because especially from operational team to product team, how to convince them that, let's say, you have to change your security to more secure way, because in most cases it works, don't touch it. What is business value, kind of?
Yeah, it's a good question. I've been thinking about it a lot lately. And so one of the things that we don't build in usually as much into the systems we build is adequate visibility. And I'll give an example. Let's say you wanted to change a cipher suite for a TLS session. And you're like, oh, I want to get rid of triple des. The first question you have to ask is, how many clients do I give up when I turn off triple des? Today, how do you figure out the answer to that question? I know what I would do, because I've done it many times, is I go and gather all the web server logs, I shove them into a database, I go and download to SSL Labs, got a JSON file, all these user agents supposedly support these algorithms, I do the join, and then I figure out, okay, I go to look at the market share data for those things, and then I pull it together, and I'm like, okay, probably I'm gonna break 10% of the web when I drop triple des. But the thing is, I can do that. I'm sure everybody in this room can do that and actually understands the relationship of those things to get there. But why is that something that a customer has to do? We don't build that into the way we've designed our systems so that it answers the question of, when you make this change, sucks to be you. You need to make an informed decision. And we don't, and oftentimes we aren't gathering enough information to help people answer the questions. And so when it comes to reducing fear and for change, data is always king. You know, here is everybody who uses our stuff. Here is the percentage of people we will break when we make a change. Here's where those people are located. You might find interesting things. I was in a conversation with a news publisher recently. Says when they deprecated triple des, turned out that everybody that was using triple des had feature phones in Africa. You know, can we deprecate triple des? You know, and so they had to, but it took them tons of time to answer a basic question: can I switch to AES? And so that's because we as software developers didn't give them the tools to be able to answer that question easily. I think if we look at the way we deploy our systems, you know, if we have the data that says this is what communicates to this infrastructure, this is what the capabilities that talks to our infrastructure, and here's the data, this data says we're safe, people are a lot more willing to let us make change. The other thing that I think comes into reducing that anxiety for change is being able to frame the value of the change in a business sense. And I think this is like the most important skill of a product person, is that they have to understand why the business cares and be able to frame the investment in something that is an enabler for the business. So for example, what would be a good example? We'll take a process that should have been automated, that somebody is on an on-call for, and you know, you all are expensive. If we were to take your fully loaded headcount cost and we look at how much we spend of your time to be able to solve a mundane problem, and we can come up with a real crude financial model for this is what it actually cost the business of lost opportunity that we could have spent on doing something more impactful. And we need to figure out ways to like tell those stories better. So data, and then to support like what the business impact is and value in something that business leaders understand. So those would be two ways that you can kind of get them to feel more comfortable and then give us the rope to hang ourselves. So.
Great. Thank you.